Could one rocket actually haul over 200 tons to various orbits, all in a single trip? How will the design of space telescopes shift once payload size is basically unlimited? And what happens to our ability to explore the universe once the cost of launching a kilogram into orbit finally crashes? These questions aren't just science fiction anymore, they're about to become reality thanks to the third version of Starship, which is honestly about to rewrite the rules of applied astrophysics and space exploration as we know it. What's the secret behind this beast? It's not just a bigger rocket, it's a total engineering redesign. It stands at a massive 124 meters tall, with a diameter of 9 meters, and it's built in 2 stages, the Super Heavy booster and the Starship spacecraft. It rocks 33 third-generation Raptor 3 engines in its first stage, cranking out an insane amount of thrust that clears 18 million pounds at liftoff. The real game-changer is its ability to restart its engines in a vacuum multiple times. The vacuum-optimized Raptor 3 engines are built to fire up in the oxygen-free environment of space, letting the ship tweak its orbital path whenever it needs to during a single mission. This feature means the ship isn't just stuck dropping cargo in one spot, it can spread out satellites across totally different orbits and altitudes. The heavy lifting capability here is actually insane. The third version can haul 100 metric tons into low Earth orbit in its fully reusable mode, and it hits a massive 200 tons in expendable configurations. To put that in perspective, the previous version only carried about 35 tons. This huge gap means that just one ship can now launch the equivalent of 5 previous missions all in a single go. How does it pull off that kind of capacity? It's all thanks to the new Raptor 3 engines, which boast a sleek design, way more power, and a massive boost in reliability compared to the previous Raptor 2 generation. The ship is also about 1.5 meters taller than earlier versions, and they've stretched the upper stage by an extra 2 to 3 meters just to pack in larger fuel tanks. These tweaks are exactly what allow it to carry so much more weight. The vehicle had its first test run back on May 22, 2026, launching from the second pad at Starbase down in South Texas. Even with one engine on the first stage and another on the upper stage cutting out during the climb, the ship still nailed its planned trajectory. That performance just goes to show how rock-solid the design is, and that it can absolutely handle engine failures without breaking a sweat. The goal of this test flight was to put some major tech to the test, including that brand new thermal tile setup and the in-orbit refueling systems. The ship even deployed some experimental satellites during its suborbital hop. These tests are totally paving the way for the operational orbital flights we're expecting to see later in the second half of 2026. The cost is honestly the most revolutionary part of the whole deal. SpaceX is aiming to slash launch costs to under $10 million per flight. That's like $80 to $200 per kilogram of payload. This price point is 10 times lower than current launch costs. Just imagine, launching a massive space telescope could end up costing less than producing a major Hollywood blockbuster. This drop in costs is going to totally end the engineering nightmare of having to fold up space telescopes. Remember how the James Webb Space Telescope had to have its 6.5-meter mirror folded up just to fit inside the launch fairing, and then it had to go through that nerve-wracking, weeks-long deployment process in space? With Starship V3, we can just launch telescopes with massive monolithic mirrors that are fully assembled on Earth as a single piece. This ability is going to seriously supercharge our quest to unlock the secrets of the universe. Instead of obsessing over making telescopes foldable, engineers can finally focus strictly on raw optical and scientific performance. Observatories like NASA's Great Space Observatories, which usually cost billions, could become way cheaper and exponentially larger. We could even launch whole fleets of observatories at once to map the universe across all kinds of different wavelengths. One of the very first missions for Starship V3 is actually going to be rolling out the third generation of Starlink satellites. Each one of these satellites rocks a mind-blowing download capacity of up to 1 terabit per second, which is literally 10 times faster than the previous ones. Just a single flight can haul 60 of these bad boys, adding a massive 60 terabits per second of capacity to the network all in one go. The crazy part is that our current Falcon 9 and Falcon Heavy rockets just can't launch these new satellites because of their size and weight. This means the whole future of global communications is officially riding on the success of Starship V3. It's not just another spacecraft, it's the absolute backbone for a totally new kind of space-based infrastructure. In-orbit refueling is the absolute key to going the distance. Without being able to top off in space, pulling off missions to the Moon or Mars on a large scale just isn't happening. SpaceX is planning to use Starship V3 as a literal space gas station, launching a tanker ship full of fuel to meet up with another vehicle in orbit and transfer all the juice it needs for those deep space hauls. NASA is banking hard on Starship V3 for the Artemis program to get humans back to the moon. That human landing scheduled for 2028 absolutely needs these kinds of capabilities. Plus, building a permanent crewed scientific base on the moon is finally within reach, thanks to these massive payload capacities and the slashed costs. The moon isn't just a destination we drop by for a visit anymore, it's becoming a place where we can actually live. At the end of the day, the real genius of Starship V3 is that it's transforming space from an exclusive playground for governments into an open arena for exploration and business. Massive telescopes, giant space stations, and crewed missions to Mars are all finally within reach. This isn't just a tech upgrade, it's a massive shift in how humanity relates to the universe, making the stars feel closer than ever before.